Hey guys, welcome back. Now we're looking at activity 40.2. We're going to be looking at mutually exclusive events. We're going to go over questions 1 through 5 that I kind of asked you to do in the last video. So in the first question, question number 1, we're talking about a dice or number cube with 6 sides. And they're talking about what are the odds of certain things happening, what are the odds of getting certain numbers. Well, it's going to be 1 out of 6 because it's 6 sides on the dice for both of them. And it asks whether or not those are mutually exclusive. And I would argue yes, because you can't show 2 sides of the dice at the same time. In B, it asks about what are the odds of getting an even number versus getting a number that's greater than 3. And so really it asks whether or not those are mutually exclusive. I would argue no. And I would just simply use counterexamples. Back from earlier, we learned about counterexamples in math. That's how you show something is false. And so for here, my counterexamples are 4 and 6, both of which are greater than 3, both of which are even. So that would show that it's not mutually exclusive. Number two is talking about looking at cars, right? And he sees 5 different, they just want you to show 5 examples, so you just put 5 colors for cars. And then the second part is saying, hey, list 2 colors, and it says to explain why they're mutually exclusive. I would argue they're not necessarily right, because everybody's seen a car with a different color fender, or maybe it has racing stripes on it, things like that. But in this particular case, they want us to talk mutually exclusive, so we would say it's not a damaged or a race car, so we'd say it's a solid color car. And so I just did A is white and B is black. Doesn't matter which colors you pick, just to make sure you have something along those lines. Number 3 talks about the idea of looking at the color of a car versus its body type. Okay, and they want you to pick a color and a body type. I picked a black for part A, and I picked a truck for part B. And I actually own a black truck, so I can guarantee that it's not mutually exclusive. It is possible to have both in one vehicle. Number 4, we talked about in the last video. It talks about if you have 2 mutually exclusive events, what is their overlap, what is the and. So the probability of A and B would have to be 0 if the events are mutually exclusive. And then in number 5, this is kind of the key of this whole section, is that if you have mutually exclusive events, then the probability of the probability of A or B is going to be equal to the probability of A plus the probability of B. If that is true, the events are mutually exclusive. If the events are mutually exclusive, then that is true. So it goes both directions. We call that biconditional, okay? So if you have a problem where this happens to be true, that's telling you that they're mutually exclusive. And you're going to see problems like that. So keep that in mind. If they tell you they're mutually exclusive, then that has to be true. It goes both directions. So what I wanted to do, we're going to talk through, yeah, I said that right. We're going to talk through number 6 through 10 on page 589, because I don't think we necessarily need to write them down, and then I'll kind of let you know what your assignment is. So number 6 says, describe 2 events that are mutually exclusive. So we could talk about the 2 different colors of car. We could talk about rolling a 2 versus rolling a 5 on dice. We could talk about being 12 years old versus being 30 years old, all kinds of things like that. We could talk about describe 2 events that are not mutually exclusive, okay? So you could be a 14-year-old and a freshman, or you could be a 12-year-old and a girl, okay? And so those are not mutually exclusive. In number 8, it says when a house is selected at random, they start talking about 2-story versus 3-story, and they say that a house basically either has to have 2 stories or has to have 3 stories. You can't have both. In fact, if you have any bit of a 3rd story at all, it's a 3-story house, okay? And so it's talking about that. And then it says, are they mutually exclusive? I would argue yes. And then find the probability that it has the or. You would simply add those 2 values. So 0.63 plus 0.13, you would add those together in 0.76. So that also tells me that 24%, 0.24% of the houses are not 2 or 3 story. Probably 1 story, maybe 4. Who knows, right? Maybe it's a big fancy neighborhood. Who knows? Number 9. We're talking about in a high school, we're talking about playing soccer and being in a foreign language class, and they want to know whether or not you can figure out what's the probability that the student does or. Well, the problem here is we don't actually know if these are mutually exclusive. Is it possible to play soccer and take a foreign language? And if so, how many of those kids are doing this? Because without that information, we can't actually answer number 9, and that's what they're asking. And then number 10, when would you use the addition rule? That is for mutually exclusive events, so you would simply have to know that the 2 events that they're talking about are mutually exclusive. What I would like you to do is actually turn the page or scroll down, right, in this online world, and we're going to go to the PDF page 590, and I want you to do numbers 11 through 14, and then come back to me and we'll go over them. And let's say, I'll give you 15 minutes, just in case this takes a little bit extra time for you, okay? So 10 to 15 minutes, and I'll see you then.